Hi children, hello, welcome to your home school. This is your next session of your class 10 mathematics NCERT or CBSE syllabus triangles chapter. It is your exercise 2.4 sixth problem. Let's start here. What's your sixth problem? Prove that the ratio of the areas of two similar triangles. So look here children, ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding medians. So medians, what do I do children? Let me draw the median. Exactly perpendicular. It will be dividing the opposite side at midpoint. Okay. So median, what does it do children? It divides exactly at the midpoint. So let's mark here D and let's mark here N. AD and PN are the medians. So what is your question? Area, the ratio of the area of triangle ABC by area of the triangle PQR is equal to square of the medians. Square of the medians means AD by PN whole square I need to prove. So look here, I have written given data here. Let triangle ABC and PQ are two similar triangles. That is triangle ABC is similar to triangle PQR. And what we need to prove? Area of triangle ABC by area of triangle PQR is equal to AD by PN whole square. And I have done a small construction. What is that children? Draw medians. AD and PN are medians. Construct these medians here. Okay, AD comma PN are medians. So now how do we start our proof? We know that we have already, what is that? Triangle ABC is similar to triangle PQR. So if they are similar, what I can say children? The corresponding ratios are in proportion. If they are in proportion, what I can write here? The two triangles are similar, then their ratios are in proportion. So let's write the ratio. AB by PQ is equal to BC by QR is equal to CA by RP. Mark it first equation. Children, how can we prove here? By using this similarity, you take ratios. And by using the areas of similarity theorem, the area of this triangle by this triangle is equal to ratio of the corresponding side square you take children. Then mark that as a second equation. Then you take a part of a triangle. So let me take this small triangle and this small triangle. Okay, as you know, these two triangles are similar. Similar means what you can say children? All the sides are in proportion and the angles are equal. Then according to that, angle B is equal to angle Q. I know already sides are in proportion. AB by PQ, BC by QR. But stop there. I don't want BC. I want only BD. BC, how can you write children? Look here, BC is nothing but BD plus DC. This is a median means what? BD is equal to DC. Right? In place of DC, substitute BD. Why in place of DC I need to substitute? In place of BD I can substitute no? I am considering this triangle. So BD should be there in question. So in place of DC, you write BD. BD plus BD will be 2BD. So this is the way I will write. Instead of BC, I will write 2BD. Okay. So, or BD is equal to half of BC also you can write. Similarly, say what is QR children? QR and QR is equal to 2QN or QN is equal to half of QR. So by that, I'll try to prove these two triangles are similar. Then I can equate their ratio. Then that ratios may be applicable in areas of triangles. Okay, I have taken first equation. Now, by Using areas of similar triangles theorem, what I can say, children? Area of triangle ABC by area of triangle PQR is equal to, any side you can write, children, AB by PQ whole square or equal to BC by QR whole square is equal to CA by PR whole square. Mark this second equation. So now, in any one of the ratio, if I am able to get median value, your answer is completed. So for that, what I am going to do? Now, consider triangle ABD and triangle PQN. Okay, children, triangle ABD and triangle PQN. So now observe carefully. I know that ratios are in proportion and angles are also equal. So now I will write here angle ABC is equal to angle PQR by given data. If they are similar, the angles are equal. And I know ratios are also in proportion. So which ratios, children? AB by PQ is equal to BC by QR. Instead of BC, I will write 2BD by, instead of QR, I can write 2QN. So 2 cancel, that is equal to BD by QN. So now what we got? 2 cancel, BD by QN we got. So now what happened here? The two sides are proportion from equation 1 we have taken. Now this side and the half of the side is proportional, right? Then side, angle, side, I can say that the two triangles are similar. By SAS similarity, I can say these two triangles are similar. If they are similar, what I can say? Remaining sides are also in proportion, you can write. That means AB by PQ is equal to BD by QN is equal to medians. What are the medians? AD by PN. Now take these two ratios, children, and take areas. Substitute AB by PQ is equal to AD by PN in equation 2. So what do we get now? Area of triangle ABC by area of triangle PQR is equal to, which ratio we are taking here? AB by PQ whole square. That is AB by PQ. Any one ratio you can take, children, don't confuse. AD by PN whole square. Therefore, area of triangle ABC by area of triangle PQR is equal to AD by PN whole square. That makes the square of the medians. Hence, it is proved. So, if any question asked for you prove, you end up your line with hence it is proved. See the 7th problem here. Prove that the area of an equilateral triangle. What is that, children? Equilateral. All sides are equal. Equilateral triangle described on one side of a square is. Okay. Where is square? Can you see here square? ABCD is a square. An equilateral triangle on one side of a square. What we have read the statement? This is a square ABCD of having, let us consider each side A units, okay. So now in this equilateral triangle, all sides are equal, right? equilateral triangle on one side of a square. What is this side? A. Then what will be this? Equilateral, no? So these sides are also equal. Okay, is equal to half the area of the equilateral triangle. One more equilateral triangle where described on one of its diagonals. So look here, from this diagonal I have drawn a triangle. This triangle is also equilateral. What you need to prove here? This triangle area is equal to half of this triangle. Okay, so not this again, big triangle. Can you see? We are going to get the big triangle by one of its diagonal of a square. So now what is given, children? Here observe carefully. ABCD be a square of having side A units. Triangle DAE is an equilateral triangle and triangle ACF is also equilateral triangle. So now what I need to prove? Area of this triangle is equal to half of area of another triangle ACF. We start our proof. First, I got this equilateral triangle side. Then what is this equilateral triangle side? So I can consider this triangle, children. This is perpendicular to each other, right? Square, all angles are perpendicular. Do you know this? So now I can remember this is a right angled triangle. Right angled triangle, can you find the hypotenuse? By what? By applying Pythagoras theorem. So let's start here. In right angled triangle ABC, let's apply Pythagoras theorem here. Hypotenuse square is equal to sum of the square of other two sides. That will be AB. A square, BC, A square. A square plus A square will be 2A square. AC square is equal to 2A square, children. But I need only AC. So what you need to do? This square, send other side. Square root. AC is equal to square root of 2A square. 2 I cannot simplify. What is AC, children? Root 2A units. So now this is root 2A and this is root 2 equilateral, no? This is root 2A and this is also root 2A units. Okay. So now what you need to do? They are equilateral triangles. They are similar. Okay. If they are similar, and what did they ask? They asked us to prove about area. So I will say here, therefore, triangle ADE is similar to triangle ACF. By one statement we have seen, all equilateral triangles are similar, right? According to that statement, I say that these two triangles are similar. If they are similar, I remember theorem 2.6. What is that? Area of similarity. So what is that one, children? Area of similar triangles, I remember. So according to that, if they are similar, then I can write area of triangle ADE by area of triangle. What is another triangle? ACF is equal to square of the corresponding sides. Square of corresponding sides. What are those corresponding sides? Any side you can take, children. I take AE and here I take AF. So now substitute here. What is AE? AF is root 2A whole square. AA cancel. That will be 1 by root 2 whole square you are left with. That will be 1 1 1. Root 2 into root 2 will be 2. Finally, therefore, area of triangle ADE by area triangle ACF is equal to 1 by 2. Did we get the answer? No. Area of triangle AD is equal to half of that you need to prove. So what is that? Just you send the denominator that side. Area of triangle ADE is equal to half of area of triangle ACF. Therefore, hence it is proved. Okay, with this we end this problem. So observe carefully, understand the concept carefully, listen the video at least 2 times. Okay, so there is nothing there in this problem. These two are the equilateral triangles. Prove that the area is equal to half of this triangle area, which is from the diagonal of the square. Okay, let's see the 8th problem here, children. See, we have last 2 multiple choice questions we have, children. Let's read the question. ABC and BDE are 2 equilateral triangles. Okay, if 2 triangles are equilateral, then what you can say? Those 2 are similar. How? All equilateral triangles are similar. Such that D is a midpoint of BC. So look here, children, let me take a triangle ABC. D is a midpoint of BC. That means BD is equal to DC. Okay, understand the question carefully. ABC is a triangle. D is a midpoint on BC. And something given, ratio of the areas of triangles ABC and BDE. So, E was there. So, I have written somewhere E on AB. Okay, I am made to join. Now, remove the triangle separate. ABC big triangle and small triangle BDE. Can you able to understand, children, here? Now, any one side I want. I know they are similar. If they are similar, the ratio of their areas is equal to square of the sides. Okay. So, any one side I want. So, they have given this is a midpoint. So, BD equal to DC. But what is BD? BD is what? I can write it as half of BC I can write. Okay. So, let me write here BC and BD is half of BC I can say. Okay. So, now or you may change in another way. BC I may write it as 2BD. So, observe here, children. Either you may change BC is equal to BD. But at a time don't change 2. Okay. Either I may change BC is what? 2BD. Or BD is what? Half of BC. Any one you change. Either this way or this way. So now what is the thing they asked? Ratio of the areas. So area of triangle ABC by area of triangle BDE, children. Take the sides, which side? BC by BD whole square. What is BC? 2BD by BD whole square, right? BD cancel. 2 2s are 4, 4 by 1. Where is your answer here, children? 4:1. This is your answer. So, if you change half of BC, if you want to write, you can write like that also. But any one only you have to write. So, now I have considered this one. I did not consider BD anything. BD as it is. That is BC by BD whole square. Instead of BC, substitute 2BD. 2BD by BD. BD will be cancelled. 2 by 1 whole square. That will be 4:1 ratio. Your answer is option C. Okay. Let's see the last problem of this exercise. Sides of 2 similar triangles. Okay. I have taken some 2 triangles, children. They are similar. Okay. Sides are in the ratio 4:9. It's not exactly 4 and 9. The ratio is 4:9. Okay, I have written here 4 and I have written here 9. So, area of these triangles are in the ratio. What is the formula here? Similar, already said. So, area of the triangle ABC by area of triangle PQR. Let me take, children, let me assume this is A, B, C, and this is P, Q, R. Okay, sides value given, but I know that according to the theorem, area's ratio is equal to square of the sides. Now what is BC given here? 4 by 9 whole square. That will be 4 square by 9 square. 4 4s are 16, 9 9s are 81. 16 is to 81. Your option D is your answer. Okay children, with this we are going to complete our exercise 2.4. We are going to meet in our next session with your Pythagoras theorem and your last exercise. Okay children, thank you.